Hi everyone, my name is Gautam and welcome to my channel where we discuss day to day updates and core concepts in natural language processing, large language models, data engineering, and analytics. On today's agenda, we have the topic Test to SQL from hype to enterprise reality. By the end of the session, you should have a good idea on schema building using SQL, data visualization using tools, test to SQL fundamentals, and benchmark datasets used to build these models. Here are some of the tech stack that we are going to cover: MySQL, Power BI, and Python for natural language processing. So, what is Test to SQL? What is all the hype around the topic? Consider this sample scenario. You have been given some employee info, which has fields such as education, joining year, city, payment type, age of the employee, gender, has the employee ever been benched or not, etc. And you want to answer few questions, such as how many employees joined at a particular location in a particular year, what is the average experience in months for a bachelor's degree holder, what is the male to female ratio at each payment tier in the organization. To answer this, traditional pipelines collect data, extract the relevant information, transform it to the required format, load it to a database, and analyze it. Once the results have been fetched, it is then reported back to the user. So let us do exactly that. I'm going to use a MySQL database for this purpose. Feel free to use any database of your preference. A link to the script can be found in the description along with a link to the employee dataset. The first step is to create a database. I created a database called employee info. I select the database and then I create the employees table using the create table command. The create table query expects column names and column types along with additional column constraints. In this case, I have added a column employee ID and set it as auto increment. This makes sure that no duplicate entries are being performed and we know what rows we are dealing with. We need to make sure the data types are correct, as MySQL expects numerical columns to be present for numerical transformations, and string functions only work on string columns. To avoid any error in future, we need to make sure the data types are as expected. Once the table is created, we can run the describe employees query to see the table structure. Before loading the file, if you are using a MySQL system like me, we need to make sure the local in file flag has been turned on. If it is not on, you can simply turn it on by setting it as 1. MySQL also expects the file to be present in a particular location. To know the location in your system, we can run the query show variables like secure file brief. And this lets us know where the file needs to be uploaded. I've already copied the employee file into the particular location and I'm gonna run the load data in file query to load it into the table employees. Once the query is run, we'll run the select star query to see the records. As you can see, none of the records have been loaded. The issue lies with data type conversion. While MySQL is able to convert string to integer, it is unable to convert a string to a boolean value. And due to this, the entire table was just loaded with nulls. There are a couple of ways to fix this. You can either load your entire table as strings and then perform the required transformations. Or we can do this using the load data in file query itself. First, let us refresh the employees table. Let us make sure the table schema is preserved while there are no records. Now I'm going to run my load data in file query again, but this time with a set query. We check if leave info is string 1, we set it to true, otherwise false. On running the query again, we see that the employee table is now loaded with an employee ID to keep track of the records. Now that the table is loaded, let us try to answer the questions. We first select the database, and to answer the question how many employees joined in a particular location in a particular year, we run the query select count of city from employees where city equal to the desired city and joining year equal to the desired joining year. This returns a count of 340. On replacing city with joining year, we should be able to fetch the same result. We can alternatively use a count star with the same filters to return the same query. But we have to be careful using count star. For example, let us run the query select count star from employee. This simply returns the total number of records in the employee table. Let us now try to insert a null record. Since we have set no constraints, this is not rejected by MySQL and it lets us insert a null record. Now let us again run the query select count star from employees. As you can see, the count is increased by 1. But if you don't want to consider the null row in your analysis, we need to provide a particular column name inside the count aggregation. And this returns only the non-null records. Moving on to the next question, what is the average experience in months for a bachelor's degree holder? We need to first filter by education equal to the required bachelor's filter, and then we take average of experience in current domain and multiply it by 12 to return the results in months. And finally, to know what is the male to female ratio at each payment tier, we need to use the group by clause. We select the payment tier and we run this particular calculation. A if statement checks if gender is equal to male, then it sets this value as 1, else 0. We finally take a sum to get the total number of male employees in this particular payment tier. We do the same for female and then we just divide these two values. If the count of female is equal to 0, it might lead to a divide by 0 error. To avoid this, we use the null if query. Let us run the query and we also get a null payment IO and a null result due to the null records that we inserted earlier. To avoid this, we can just add a where clause where payment tier is not null and rerun the query. This fetches the desired result. As we can see, payment type 1 and 2 is a bit female leaning compared to payment type 3 where there are 2 male employees for every female employee. So, what were the major issues that we just faced? We needed to know if our table contained null records and whether to include this in the analysis or not. We needed to know the column names of the table and we also needed to know the values in these columns to ensure proper filtering, like in this case. Even before analyzing the data, we had to make sure we had the correct table structure and the correct file permissions. What if you just want to load and analyze your data without spending much time in making sure tables are loaded in the proper format? Tools such as Power BI, Google Looker Studio, and Microsoft Excel to an extent can help. If you want to take it further and perform even more advanced analysis, tools such as IBM SPSS, R, Sigma Excel, SAS, and Minitab are useful resources. Let us go back to the sample scenario and now let us try to solve this using a Microsoft Power BI tool. We start with the blank report on Power BI. We go to the Get Data option, then text/CSV to load the particular CSV file of interest. Once a connection has been established, Power BI provides us with a nice preview of our data. If you wish to transform the data, we can simply click on Transform Data, and this opens up a new Power Query window. The Power Query has automatically performed some of the transformations for us, such as converting joining year and payment year to numerical. If you want to change any type, we just right click on the column, change type, and change it to the desired type. Since payment type is a classification column, we change it back to text. To change the leave or not data, we first change its type from whole number to decimal number. And then we change the type from decimal to true or false values. We can add this as a new transformation step or replace the current step. We can also rename or delete the transformation steps. Once you're finished with your transformations, to load, we simply click on Close and Apply. Once the data has been loaded, you can see all the columns that are available in the data pane. To have a look at the table, we can go to Table View, and this provides us a view of all the rows present in the table. We can just look at the model schema by going to the model view. To answer our question, we just drag and drop any desired visualization. In this case, I'm going to use a line and stack column chart. Once the chart is loaded, we simply drag and drop the required columns. In this case, we need to analyze city and the joining year. We also need the counts, so we simply drag and drop it into the y-axis. We change the aggregation from sum to count for joining year. We can also have joining year as a line on the y-axis instead. Now this provides us with a nice visualization that summarizes our entire data. And we can click and analyze the desired city and the desired year. To answer the question of average experience in months, we can use the card view. And once the chart is loaded, we simply drag and drop education and the experience. We change from sum to average. And since we need only the education level equal to bachelor's, we go to the filter pane and then filter by education equal to bachelor's. Now, to add a new calculation, we simply right click on the visualization and go to new visual calculation, go to custom, and we can simply perform the desired calculation. In this case, we multiply it by 12 to return the result in months. We rename the column to experience in months, and just like that, we have the desired result. To answer the final question of male to female ratio, we can simply use a matrix view. Once the matrix view is loaded, we drag and drop columns of interest. In this case, it's gender as columns and payment type as rows. Power BI automatically loads the table structure for us with the unique values present in these columns. Now, to fill the actual counts, we drag and drop gender into values and change gender from first gender to count. To view the results as percentages, we go to show value as and view it as percent of row total. This gives us a ratio of male and female at each payment type. How does this compare to the previous approach of using plain SQL queries? We were able to quickly load and transform our data with few clicks. The Power BI provided us with interactive visualizations and dynamic filters that allows easier data exploration. But the major limitation still remains. We need to know the tool and we need to know what columns to aggregate by and what aggregation to use. What if we could do this? We load the data, ask a question, have a model generate the SQL query, run the query on the data, and return us the results. Let us jump back into the Power BI window. This time, let us use a Q&A visualization. The Q&A visualization in Power BI lets the user ask a question and returns the relevant visualization as result. Let us try this out. Number of employees who joined in the year 2013 at location Bangalore. Power BI is able to detect that joined in the year, even with the spell check, corresponds to the joining year column and location corresponds to the city column. Now let us try what is the male to female ratio at each payment tier. While Power BI is able to detect the user question, it is unable to perform this particular analysis since it is not able to come up with a query that can fetch this particular results. This is exactly what Text2SQL is about. Text2SQL can be defined as a pipeline, framework, or a model that translates your natural language questions into valid SQL queries. This enables even non technical users to query databases as they don't need to know complex SQL queries. It can improve efficiency as we don't have to spend a lot of manual hours writing and refining these queries. It can also reduce manually introduced errors as automated pipelines can take care of query syntaxes. It can improve productivity as we as users can focus on analyzing the data rather than worrying about the correct SQL query or having to learn a new tool. So, how are the models built? Training a model involves feeding it a lot of data. Data can be of the format natural language questions paired with SQL queries. In some cases, researchers also provide the table schema and the expected SQL result as input to train the models. It's like teaching the model when you see this particular question and this particular schema, this is what you should write and this is what it should produce. Most modern text to SQL models use encoder decoder or decoder only architecture in its background. An encoder decoder model such as T5 or BART takes the natural language question and schema and converts it into relevant tokens. Tokens are then fed into the model, which produces output tokens which correspond to the required SQL query. A decoder only model, such as large language models, takes the user prompt as input and based on the instructions in the prompt produces an SQL query. To take a deeper look in the topic, let us take a look at the dataset Salesforce Wiki SQL. This dataset was introduced as part of the Sequence to SQL paper, which focused on generating structured queries from natural language using a reinforcement learning algorithm. So, what did the authors do? The authors had question and schema pairs and fed it to a model and asked it to generate a corresponding SQL query. The query was then run on a database and the results were fetched. If the fetched results matched the ground truth results, a reward was provided as part of its learning algorithm. The sequence to SQL model had three main components: aggregation classifier, a select column pointer, and a where clause filter. Given a user question and column names, sequence to SQL was able to generate a relevant SQL query using these three main components. Let us take a look at the WikiSQL dataset that was used to train this particular model. The dataset consisted of a table, user question, corresponding SQL query, and the expected result. Questions were of the kind what, which, name, how many, who, and others. The query length and query complexity was fairly simple, with the dataset being dominated by questions of the kind what. At the time of release, WikiSQL was the largest dataset of its kind. Let us test the model. We'll use a T5 base fine-tuned WikiSQL model. It has a T5 model at its core and is trained on the WikiSQL dataset. It is available publicly on Hugging Face. As a first step, we need to install the package transformers from Python. Once the package has been installed, we can import the required tokenizer and required model using the model path. Once the tokenizer and models have been imported from transformers, we can write a simple Python function that takes query and schema as its arguments and outputs a relevant SQL query. The input text to be provided is of the format translate English to SQL given a particular query and a particular schema. The entire text is then converted to tokens and the output is written token by token. Let us try to run the function and then run the query what is the number of employees who joined in the year 2023 at location Bangalore. Even with the table schema provided, the model is not able to fetch a query that is in line with the provided schema. Let us try a different question. What is the average experience in months for a bachelor's degree holder? This returns a result select average experience of months from table where degree equal to bachelor's degree. This is not really a correct SQL syntax. What if we use a model that is trained on a better dataset? Spider is a large-scale human-labeled dataset for complex and cross-domain semantic parsing. It was written and reviewed by 11 computer science students who went to Yale. The authors spent a significant amount of man hours collecting pairs of natural language question and corresponding SQL queries. Queries consisted of complex questions, which required complex SQL syntax. Spider had having, group by, order by, and complex nested queries, which was missing in other benchmark datasets present at the time. Authors divide the question into four levels of difficulty: easy, medium, hard, and extra hard, each corresponding to a different level of difficulty in SQL queries. Although the size was significantly lower compared to SQL, the complexity of the dataset is where it shines. Spider was also the only dataset at its time which had multiple tables in different domains. Let us now load another model which uses T5 as well, but is trained on the Spider dataset. Once the required tokenizer and model is loaded from the model path, we can write a Python function that takes the user question and schema and returns the corresponding SQL query. Given the user question, what is the total number of employees who joined in the year 2013 at location Bangalore? Spider also expects the schema to be in the following format. We provide the table name, the column names, and corresponding column types. We can also provide additional constraints such as primary key and foreign key references. Models trained on Spider can also handle multiple tables in the schema. This returns the query: select count star from employees where joining year equal to 2013 and city equal to Bangalore. Let us try to run the query in our MySQL server. On running the query, we get the exact result as expected. Let us now ask the model the question: what is the total number of employees in each year and each location? This should fetch the results of all years and all locations. The model returns the query: select sum of joining year, comma city from employees, and it groups it by city. Let us try to run this query in our server. On running the model produce query, we get this particular result, which is not really correct and which is not really what we are looking for. Let us try to run a simpler, rephrased version of the question: what is the number of employees at each location and each year? On running this query, it selects city joining year from employees grouped by city and joining year. This is not really what we need, as we need the count. Let us move on to the next question. What is the average experience in months for a bachelor's degree holder? The model returns the query: select average of experience in current domain from employees where education is equal to bachelor's. Although the model is able to map the correct columns, this is not really the transformation that we are looking for. The model is simply not capable of converting the year into months, as it does not know the actual values that are present in this table, and it is not trained to do so. Given all the inconsistent results, what is all the hype around the topic? Some better models are able to perform really well with proper schema mapping and better prompts, but models are still not aware of where we are running these queries. For example, the same query which runs successfully on a MySQL server may fail on our Oracle DB server. Accurate instance mappings can be tricky. For example, bachelor's is not as same as bachelor. This might require us as users to first explore the data before providing the natural language question. Prompts might not be straightforward as the query complexity increases. We might have to do some trial and error with a natural language question to finally land on an accurate resulting SQL query. And most importantly, the models are limited to the datasets that they are trained on. If an encoded decoded model is not trained on a complex enough SQL dataset, it simply cannot produce a complex SQL query. So, what if we use large language models such as GPT-4o or Llama? These models are trained on all sorts of data. They are optimized for a various number of user tasks, and they can perform really well with no pre-training with only few short examples. This is exactly what we'll try to explore in the next episode: Text to SQL Hype versus Reality. We'll also see if models can be reliable at an enterprise scale, and we'll also explore the current developments in the field. Thank you for watching. All the demo files used in this video can be found in the description along with other relevant information. Until we meet again.